This video is designed to provide an overview of independent and dependent variables, which were covered in chapters 18 and 19 of the Heppner, Wampold, Owen, Thompson, and Wang text, Research and Counseling 4th edition, published in 2016 by Cengage Learning. This video is not intended to replace a comprehensive review of the source material. Please refer to the chapters listed for additional information. In its simplest form, an independent variable, or IV, is a variable in an experiment that the researcher manipulates or changes to test the dependent variable, or DV. It represents the cause or reason for an outcome, which is why it is considered the driver of the study. Before an experiment begins, the independent variable must be adequately designed or operationalized. This slide lists 4 concerns particularly important to the researcher regarding operationalizing the IV. First, we have to determine the conditions or levels of the IV. The conditions of the IV are determined by the researcher. This determination is often referred to as the experimental manipulation because the researcher manipulates the IV to determine what effect it has on the DV. Next, adequately reflecting the constructs of interest. This process is to state the research question so clearly that there are no alternate explanations for the cause of an effect. When the conditions vary on a dimension other than the intended dimension, a confound is said to exist, and it is not possible to ascertain whether the construct of interest or the confound is the cause of the effect. Third, limiting differences between conditions. Often, constructs represented by an IV are operationalized by selecting various exemplars or typical examples of the construct, or by using various stimuli, sometimes called stimulus sampling. Variability is important, as is making sure they are representative of how they would exist in the natural world. And lastly, establishing salience of differences in conditions. The intended differences among the conditions of the IV must be salient or noticeable so that they have an effect on participants, but not so vivid as to become transparent to the participants. Participants within a condition should be aware of the critical component of the condition, but not be able to infer the research hypothesis. If the IV does indeed vary on the intended dimension and is salient to participants, then between-group variance is maximized. In many counseling studies, status variables are included in the design and analysis. As previously mentioned, IVs are manipulated and the effect on the DV is assessed. If everything goes well, a causal relationship is established. In contrast, status variables are variables that cannot be manipulated by the researcher, such as personality variables, socioeconomic variables, gender, and ethnicity. Manipulation checks show that the conditions varied on the intended dimension, that conditions did not vary on any other dimension than the one intended, and/or treatments were implemented in the intended fashion. Care should be taken because a manipulation check can also introduce reactivity if it is not conducted properly. Let's take a look at a practical example, the parable of the sower as found in Luke chapter 8, verse 11 through 15. In this parable, the sower sows his seed on 4 different types of soil, which produce 4 different outputs. The focus of our research would be, what does the impact of varying the type of soil have on crop production? The IV in this scenario is the soil. This graphic depicts the 4 conditions of our experiment: hard-packed trail, stony ground, thorny ground, and good soil. The only dimension we are manipulating is the type of soil. The amount of air, sun, and water, all limiting differences, remain constant between conditions, so we are not introducing any confounds. The differences between the types of soil are salient as there are no other differences in the mineral makeup of the soil. In this case, the sand, silt, and clay that make up the soil are status variables which cannot be manipulated by the researcher. The Bible tells us the outcome of this experiment, but we can also perform a manipulation check by checking moisture content to ensure all conditions receive the same amount of water, or verifying that the seeds were all of the same gene variety. Let's switch gears a little bit to talk about interpreting results. Statistical significance indicates the results for each of the conditions are sufficiently different, and consequently, the null hypothesis of no difference is rejected. In other words, there appears to be a true difference among conditions. A word of caution. Statistically significant results are hard to interpret because there may be another explanation for the results other than the intended one due to false positives, false negatives, the design measured another dimension, or reactivity due to the manipulation check. Statistically non-significant results can be due to several factors other than the lack of a true effect, including inadequate statistical power or not having sufficient number of participants to find a significant effect if one exists, insensitive instruments, violated assumptions of statistical tests, careless procedures, and bias. This concludes Chapter 18. We have just covered a lot of material related to operationalizing the independent variable. Clearly, design of the IV is a critical step in research. It is not unusual for researchers to have confidence in their manipulations only to discover after the data has been collected that a threatening confound was present. It is best to always try to think of every possible problem with the IV before the study is conducted. Next up is Chapter 19, the DV.
Now that we've looked at the independent variable, let's take a look at the dependent variable, which Heppner covers in Chapter 19. There are 4 considerations when choosing a dependent variable: the research question, psychometric properties, the reactivity of the variable, and procedural issues, which includes data collection methods. Let's take a closer look at these things. Your first consideration should be your research question, obviously. If the independent variable has its anticipated causal effect, what should change? What should be different? What constructs are affected and are varying? This is based on your theory and should be the primary consideration when choosing a dependent variable. The second issue you should consider is psychometric issues. You might be measuring that construct or the changes, but how can you do so in a way that's accurate, one that's actually getting at what you want to measure? This brings us to issues of reliability and validity. To understand reliability, you need to keep in mind that any score you obtain is always due to a variety of factors. Part of it should be due to actual changes in the participants, which is what you're trying to measure. But part of it is also due to other factors. This is called error. For example, somebody might misread a question and answer it wrong. This is a type of random response error. The instrument might have an item that's worded poorly, and one person reads it one way and answers it one way, and another person reads it a different way and answers it differently, even though they're the same on the construct it's intending to measure. This is a type of specific error. There's something specific to the instrument that's leading to variation that's other than the construct. So there are many kinds of error. The point is you're trying to minimize that in your study. Reliability is the degree of the variance in the obtained scores which is due to actual changes in the participants. This is written as a reliability coefficient as a decimal. If you convert that decimal to a percentage, it gives you the percent of the obtained score which is due to actual changes in the participants. What changes is not a question of reliability. The remainder is always due to error. 0.7 is usually considered sufficient for most uses, although there are additional considerations. You should also remember that reliability is specific to the participants and the conditions under which the reliability estimate was formed. Thus, it's usually best for you to do your own reliability estimate for your study and not rely on the reliability estimates of the instrument creators. There are different types of reliability. Internal consistency, test-retest correlation, and innovator agreement are just 3. It's also important to remember that correlation or variation between variables is not equal to correlation or association between constructs because of unreliability of your measures. In order to get at the actual correlation between the actual constructs, you have to take that unreliability out, and you can see a formula here for doing that and look at Heppner, page 452, for more detail. The second psychometric issue you should consider is validity. There are many different types of validity, but for the dependent variable, the most important type is construct validity. Construct validity is the degree to which the scores reflect the desired construct and not some other construct or combination thereof. Are you actually hitting the target you are aiming at, or are you hitting a different target, or are you hitting multiple targets? The way to determine construct validity is to look at how the instrument was created. For example, the first step is to establish content validity. Did the creators generate the items and tag those items to the experts and say, are these items related to the construct we're intending to measure? So that is a form of content validity. After that, they use factor analysis to see which items group together and seem to be measuring the same thing. Then they use convergent validity. Did this instrument have high correlations with other instruments that are measuring the same construct, showing they're measuring the same thing? And then there's discriminant validity. Did this instrument have low correlations with other instruments that are measuring similar but different constructs? Can it distinguish between the two? In order to increase your validity, it's advisable to have multiple dependent variables from different instruments. This has several advantages. One, it accounts for specific error. Because you're using multiple instruments, those instruments do not share the same specific error and can not inflate your correlations because of that. Also, different measures tend to be sensitive to different aspects of the same concept or construct. Thus, you get a more robust measure of that construct by using multiple dependent variables. Also, you can use statistics to get at the correlation between the constructs without unreliability being an issue, and you can account for method variance, which we'll explain later. After you've considered your research question and the psychometric issues, the third consideration is your reactivity. A reactive variable is a variable that affects the characteristic it intends to measure. For example, if you're trying to figure out how often your dog sleeps on the forbidden couch, and you pull your chair up and just stare at the couch, seeing how often the dog gets up there, I would guess that that dog probably isn't getting up there as often as it usually does. That variable is highly reactive. Knowledge of which variables are reactive is something you gain from study of the literature and experience, and you can decrease reactivity by using unobtrusive measures if a variable is highly reactive. The fourth consideration is procedural issues. These are the logistics that come to bear on your study. For example, you may wish to give 4 different personality tests to your participants, but finding participants who are willing to give you 8 hours to take all 4 of them and don't get fatigued and just start filling in bubbles, that might be pretty hard to do. So you choose 1 or 2. Another might be reading level. If you're testing elementary school students, you want to make sure the reading level of the instrument is fair to them. Also, order of administration of instruments. For example, if you're doing a study on personality and anxiety, you want to give the anxiety measure second. If you give it first, it might sensitize the participants and they might answer the personality questions differently because they know what you're trying to test. Another consideration related to procedural issues is methods of data collection. How do you get the data? Here are 7 different ways of doing so. Each has its strengths and its weaknesses. You can look at Heppner for the details. The main thing to note here is that it's often advisable to use different forms of data collection within the same study. This is due to what's called method variance. Each method of data collection, if used solely within a study, will inflate your correlations. There's some sort of difference between the data collection methods which throws off those scores. So if you use multiple methods of data collection, it reduces method variance and helps you get a more accurate correlation. So there you go. 4 considerations when choosing your dependent variable: your research question, obviously and foremost, psychometric properties such as reliability and validity, the reactivity of the variable, and also procedural issues including data collection methods. We hope that this survey of the independent and dependent variable has been helpful to you and aids you in your research endeavors.